Bismillahirrahmanirrahim. Chapter number 1, Matrices and Determinant. The type of matrices. The first is row matrix. A matrix is called the row matrix if it has only one row. Example M, it contains one row, two column. Second is a column matrix. A matrix is called a column matrix if it has only one column. Example N is equal to 2, 0, 1. It containing one column and three rows, so it is called column matrix. Next one is the rectangular matrix. A matrix is called the rectangular matrix if the number of rows are not equal to number of columns, so it is called the rectangular matrix. Example B is equal to one column and three rows are there. Rows and columns are not equal, so it is called the rectangular matrix. Next one is a square matrix. A matrix is called the square matrix if it has all the number of rows are equal to number of columns. Example A is equal to 2, 1, 0, 3. There are two rows and two columns, so number of rows are equal to number of column. It is a square matrix. Next, null matrix. A matrix is called a null or zero matrix if each of its entries is 0. Example D is equal to 0, 0, 0. All the entries must be equal to 0. Next, transpose of a matrix. A matrix is obtained by changing the row into the column and column into the rows of the matrix. It is called the transpose matrix. If A is the matrix, then transpose is denoted by the A transpose A par T. If A is equal to 0 and 1, the one row and two column, it is changed into one column, two row. Next, negative of matrix. Let A be the matrix, then its negative, it is equal to minus A. It is obtaining by changing the sign of all the entries. If A is equal to 1, minus 2, 3, 4, it negative is equal to plus 1 is changed into minus 1, minus 2 is changed into plus 2, minus 3, minus 4. Next one is a symmetric matrix. A matrix is a symmetric if it's equal to its transpose. When we take a transpose of the given matrix, then it is again equal to the given matrix, so it is called the symmetric matrix. A transpose is equal to A. Example, if A is equal to 1, 4, 1, so its transpose is also equal to 1, 4, 4, 1, so it is called the symmetric. Next, skew symmetric. A square matrix A is said to be skew symmetric if A transpose is negative of A matrix. If we take the transpose of the given matrix, then it is equal to negative of the given matrix, so it is called the skew symmetric. If A is equal to 0, 1, minus 1 and 0, taking a transpose, it is equal to 0, plus 1 is changed into minus 1 and minus 1 is changed into plus 1, so it is equal to negative of the given matrix, so it is called the skew symmetric. And diagonal matrix. The matrix A is called the diagonal matrix if at least its one diagonal entry is not 0 and other non-diagonal entries are 0. 1 and 2 are the diagonals, they are not 0, so all the other entries are 0, so it is called the diagonal matrix. Next, a scalar matrix. Scalar is the type of a diagonal matrix. In a scalar matrix, if all the diagonals are same and non-zero, the example is a 2, 2, 2. The diagonal matrices, the diagonal of the scalar are equal to 2 or other entries are equal to 0, so it is called the scalar. Next, identity matrix. A diagonal matrix is called identity or unit matrix if all the diagonal entries are equal to 1. It is denoted by I, so it is equal to the diagonals are 1, 1, 1 and other entries equal to 0.